Okay, welcome to another tutorial on stoichiometry. This time we will be focusing on limiting and excess reagents, okay? So reagents are what's on the left side of the chemical equation, okay? So here is the problem. 0.07 moles of silicon reacts with 25 grams of bromine. The product is silicon tetrabromide, okay? Which one is the limiting reagent? So which one, silicon or bromine, is the limiting reagent? Limiting reagent means which chemical gets used up first. And because it gets used up, the reaction stops. Okay, because there's no more of that particular chemical. So which one gets used up first, silicon or bromine? Okay, the product is silicon tetrabromide, and we know that tetra means 4. That means in this compound there is 1 silicon atom and 4 bromine atoms. Okay, so what is the first step? The first step is to write the equation. So let's look at this. We know there will be silicon, and we know there will be bromine, and we know that the product is silicon tetrabromide. So let's write that down. So silicon is Si plus bromine is Br, and it becomes SiBr4 because silicon tetrabromide. Okay, now I already see that there's a problem here. Now bromine is a diatomic element, so that means if it's by itself, it needs to be, okay, with another bromine atom, okay? So now this is the correct way of writing it. Silicon plus bromine is equal to, produces silicon tetrabromide. Now the second thing you need to do after doing the balance, after writing the equation, is you need to make sure, is it balanced, okay? So let's check. So we have silicon and bromine, okay? Over here, we have 1 silicon atom and 2 bromine atoms. But on the other side, the product side, we have 1 silicon atom and 4. So it is not balanced, okay? So if we look here, 1, 1 is fine, but there's only 2 bromine atoms here, but there's 4 here. So we need to adjust, and we know that when we are balancing equations, we adjust the side that has less, okay? So in this case, I need to increase this. Now, you can never change the chemical formula, okay? The only way you can increase the number of atoms that you need is to increase the number of molecules. So in this case, I need to increase the number of bromine molecules. So now we have 2, and we know that we have 2 times 2, so now we have 4. Therefore, we have a balanced equation, okay? 1 silicon, 2 times 2, 4 bromine, 4 bromine, okay? So now let's go to the limiting reagent. Now that the equation is balanced, let me rewrite it, okay? So this is our balanced equation. Silicon plus 2 bromine gives us silicon tetrabromide. Now let's write down the important information. What is important? We know that there's 0.07 moles of silicon. So I'm going to write that down, note that down, and then we know there's 25 grams of bromine, okay? So let's make a table, okay? So I would put here mass, and then relative atomic mass, and then we can calculate for the number of moles, okay? Now, since silicon already has the number of moles given, I can just write 0.07, okay? Now, bromine, we only know that it has 25 grams, okay? Then we know the relative atomic mass, oh, sorry, I forgot to write it too, of bromine is 80. Okay, so the AR of bromine is 80, but we have Br2. So I'm going to use 160, okay? And therefore, we can calculate the number of moles of bromine to 0.15625, okay? So once we have that, we can use ratio and proportion to determine which is the limiting reactant. Okay, so I only have one molecule of silicone. Since it's one molecule, we don't need to write the coefficient 1, okay? But I just wrote it there so you can see it. And we know that one molecule of silicone gives us 0.07 mole, okay? Now let's look at bromine. We have two molecules of bromine, but we don't know. We need to find out how much bromine do we need to react with 0.07 mole of silicone. So I don't know what it is, so I put X. Then we cross multiply, so we have X is equal to 0.14 mole. What does this mean? Okay, this means that 0.14 mole of bromine is needed to react with 0.07 mole of silicone. Okay, so this is what we have. At this point, 25 grams of bromine gives us 0.15625 mole. But what do we need? We only need 0.14 mole of bromine to react with 0.07 mole of silicone. So as you can see here, have is greater than need. That means I have more bromine than what I need. Therefore, bromine is not the limiting reagent. Because we have more than what we need. So that means silicone is the limiting reagent. So silicone is the limiting reagent. So let's just test. So let's use bromine. So we have silicone. Let's say we don't know how many moles silicone we have. So that's 1 over X. How much silicone do we need to react with 0.15625 mole of bromine? So we cross multiply. We have 2X is equal to 0.15625 divided by 2 divided by 2. Therefore, X is equal to 0.078125 of silicon needed. That means we need this much silicone to react with this much bromine. But let's look at how many moles of silicone we have. We have 0.07. If we are reacting with 2 molecules of bromine, we need 0.078125 mole. So as you can see, the have is less than what we need. So if what you have is less than what you need, that means that is the limiting reagent. So as we can see, we have proven that silicone is the limiting reagent, meaning silicone will get used up first, and then bromine would be the excess reagent because the reaction is over and we still have leftover bromine. So let's look at the next question. So we already know what the limiting reagent is. It's silicone. So we need to keep that in mind when we calculate for how many grams of the product will be produced, because we have to base everything with the limiting or on the limiting reactant, not the excess. So what are we going to use to calculate this? We need to use the values for silicon, since silicon is the limiting reactant. So let's begin. So we know okay, Si silicon plus 2 bromine gives us, okay, 1 molecule of silicon tetrabromide, okay? So we have 1 molecule of silicon, 1 molecule of silicon tetrabromide, and we know that one molecule of one atom of silicon gives us 0.07 mole, okay? So let's do that. 1 over 0.07 will give us 1 over x. We need to calculate the number of moles. Once you know the number of moles, then we can calculate for the number of grams, for the mass, okay? So this one shows cross multiply, if you remember that, okay? X is equal to 0.07 mole. That means when silicon reacts with the bromine, okay, since this is the limiting reagent, okay, and since there's also 1 unit of this one, there okay, they will have the same number of moles, okay? So that means 0.07 mole of silicon tetrabromide will be produced as well. So how will we move this into grams, okay? So to find the mass, we need to multiply the molecular mass of silicon tetrabromide by the number of moles, which is 0.07, okay? So what is the molecular mass of silicon tetrabromide? So SiBr4, silicon has an atomic relative atomic mass of 28, plus bromine is 80 times 4 because we have 4 molecules, so that's 28 plus 320 gives us 348. Okay, so this is equal to 348 times 0.07, which will give us 24.36 grams. Okay, so that means in this reaction, with silicon as the limiting reagent, we are going to produce 24.36 grams of silicon tetrabromide. Okay, we're almost done. I am just going to add one more question here. So let's calculate for the excess. We know over here that we have this much bromine, but we only need this much. So what do you need to do? Okay, so we're looking at how much excess, okay? So we take, how much do we have? 0.15625. But we only needed 0.14 mole to react, okay? So minus 0.14 gives us, okay, let me just use my handy dandy calculator to be sure. 15625 minus 0.14. Okay, gives us an excess of 0.01625 mole. Okay, so this is the excess. So if the question is asking you how many moles are in excess, then this is the answer. This is the answer. However, if the question is asking you how many grams, okay, are in excess, what do you do? Okay, you multiply the number of moles by the molecular mass. Okay, so in this case we have Br2 and it is 160. So 0.01625 times 160 grams gives us an excess of 2.6 grams. Okay, so that means out of the 25 grams, okay, how much was used? We only used 22.4 grams and 2.6 grams, okay, 2.6 grams was not used, did not react. So how did I get 22.4? It's 25 grams minus the excess, 2.6, okay? So that means 22.4 grams of bromine reacted with silicone, okay? And out of that, 2.6 grams of bromine was in excess, okay? So I hope this tutorial helped you understand how to calculate for limiting and excess reagents and also of their products, okay? Make sure always, big tip, organize your work so that you don't get confused. Second, okay, if you put it in a table form, that's another way of organizing it. Third, always label your answers, label what it's all about so that you're not confused which one is silicon, which one is bromine, okay? And it will save you time, especially when you have assessments that are time sensitive, okay? Hopes this helps. Bye bye.